Let's solve the following linear inequality. So here we will begin by taking two cases. Case number 1, we will consider that x plus 3, let this be greater than or equals to 0. If x plus 3 is greater than or equals to 0, it simply means that x is greater than or equals to negative 3. Now, when this is the case, we can say that the absolute value of x plus 3 is also the same as x plus 3. That means we can rewrite our linear inequality as x plus 3 plus x divided by x plus 2 greater than 1, which is 2x plus 3 divided by x plus 2. So we'll transpose 1 to the left hand side. So we have minus 1. This is greater than 0. Now we'll combine the two terms. So this should give us 2x plus 3 minus x minus 2 divided by x plus 2 greater than 0. So 2x minus x will be x. So we have x plus 3 minus 2, which is 1. So we have x plus 1 divided by x plus 2, which is greater than 0. Now we need to find a solution to this linear inequality, x plus 1 over x plus 2 greater than 0. So for doing that, we will begin by considering critical values. So critical values are defined as those values of x for which the numerator, which is x plus 1, goes to 0, as well as the denominator also goes to 0. That means when we have x equals to negative 1, the numerator will go to 0, and when x equals to negative 2, the denominator goes to 0. Then, using these two critical values, we will use a number line. On it, we'll plot the values. So we have negative 2 and negative 1. So here, we'll consider this, we'll consider some values of x which is going to be less than negative 2, lying between negative 2 and negative 1, and values greater than negative 1. So let's consider. Before doing that, let's divide this into three regions. So we have region 1, which is all values of x less than negative 2. Region 2 will be all values of x lying between negative 2 and negative 1. And region 3 will be all values greater than negative 1. So we will consider region number 1. Here, let's say we take the value of x to be equals to negative 5. Then we will substitute x equals to negative 5 into our expression x plus 1 divided by x plus 2. So that means we will have negative 5 plus 1 divided by negative 5 plus 2. So that's going to give us negative 4 divided by negative 3. So the negative and negative cancels out. That leaves us with a positive value. So we are only interested with the sign. Then we will consider another value of x. Now x will be chosen in such a way that it will be lying between negative 2 and negative 1. So let's say we take negative 1.5. So that means our expression will become negative 1.5 plus 1 divided by negative 1.5 plus 2. The numerator will be negative and the denominator will be positive. So we have a negative number divided by a positive number, which makes it negative. So that means our region 2 will be negative. And coming to third region, so we will consider a simple value. Let x be equals to 0. So 0 is greater than negative 1. And when we substitute this value into our expression, so we have 0 plus 1 divided by 0 plus 2, which is positive half. So that means in region 3, we have the positive sign for a given expression. Now clearly, here it's stated that x plus 1 over x plus 2. So this must be greater than 0, though we will consider only the region where it's giving us positive value. So one region will be region 1 and the other region will be region 3. So here we can say that our solution to this linear inequality with x will belong to the interval negative infinity to negative 2 union negative 1 to 0. So here we have used an open interval because negative 2 and negative 1, these are not part of the solution, and this is infinity, positive infinity, and infinity and negative infinity by definition are unbounded. Now, when we started out with our case, we also considered that x must be greater than or equals to negative 3. So that means if we consider negative 3, so here we have x greater than negative 3. So that means we cannot consider values less than x equals to negative 3. So that means it will be not actually from negative infinity to negative 2, but x will actually belong from negative 3 to negative 2, union negative 1 to positive infinity. So this is the value of x that we obtained for case number 1. Now we'll have to go to the second case. So let's try that out. So in case number 2, we will begin by considering x plus 3 to be less than 0. We have already considered it to be equals to 0, greater than or equals to 0. So this time we will consider x plus 3 to be less than 0. So we are not including 0 here. So this would mean that x must be less than negative 3. Now when this is the case, then the absolute value of x plus 3 will become equals to negative of x plus 3, or simply negative x minus 3. That means our linear inequality can be rewritten as negative x minus 3 plus x divided by x plus 2. And we have greater than 1, so we'll transpose 1 to the left hand side and solve the two terms. So here negative x and positive x goes away. So that leaves us with negative 3 divided by x plus 2 minus 1 greater than 0. So we'll combine them. So combining them will give us x plus 2, which is the common denominator. In the numerator, we have negative 3 minus 1 multiplied to x plus 2. So this is greater than 0, which gives us negative 3 negative x minus 2 divided by x plus 2 greater than 0. We'll combine them. So we have negative x minus 5 divided by x plus 2. So this is greater than 0. Now we'll take negative as the common factor in the numerator. So we have x plus 5 divided by x plus 2. So this is greater than 0. And we want to get rid of this negative sign by multiplying negative 1 to both sides. But we have to be careful. Whenever we multiply with a negative number, the sign of the inequality changes. That means x plus 5 divided by x plus 2. So we multiply with negative 1 to make it positive. This will become less than 0 times negative 1, which is 0. Now what our task will be is to solve this particular linear inequality. So let's do that. So similar to the previous method, what we'll do, we'll begin by finding out critical points. So critical points will be x plus 5 equals to 0 and x plus 2 equals to 0. So x plus 5 equals to 0 gives us x equals to negative 5, and x plus 2 equals to 0 gives us x equals to negative 2. So what we'll do, we will consider a number line. On the number line, we will have x equals to negative 5 and x equals to negative 2. So this divides the number line into 3 regions, 1, 2, and 3. And we will consider 3 values of x in each of the region. So in region number 1, we'll suppose that let x be equals to negative 10. Then our expression, which is x plus 5 divided by x plus 2. So if we substitute x with negative 10, this gives us a positive value. So that means 1 will be a region of positive values. Then we come to region number 2. So region number 2, we will consider x to be equals to negative 3. So here we have x plus 5 divided by x plus 2. So the numerator will be positive while the denominator will be negative, because we have negative 3 plus 2, which is negative 1. So that means we have a positive number divided by a negative number. The sign will be negative. Region 2 gives us a negative value. Then in region number 3, we'll consider a value, let's say x to be equals to 0. Then in that case, our expression will become 5 over 2, which is a positive number. So it's a positive value in region number 3. But we will only consider the particular region where x is negative. That means where the expression x plus 5 over x plus 2, that is negative, and this is the only region, which is region number 2. Now that means we have x greater than negative 5 and x is less than negative 2. However, we have also considered the case that x is going to be less than negative 3, so that we also have to include into our solution. That means x is less than negative 3. So let's try to understand with the help of a number line. So we have negative 5, negative 3, negative 2. So from case number 2, we have obtained that the solution of x is going to lie between negative 5 and negative 2. Whereas we have x also less than negative 3. So x less than negative 3 means all the values of x lying to the left of x equals to negative 3 and extending up to negative infinity. Now if we try to find out the common region that satisfies both of the two inequalities, this is the only region, and we can say that x must be lying between negative 5 and negative 3. Now that we have obtained the solution for both case number 1 and case number 2, we are going to combine it. So from case number 1, we obtain this particular solution, and case number 2 gave us this solution. So that means these are the two solutions, and our final task will be to combine them. So let's do that with the help of a number line. So on the number line, we will consider negative 5, negative 3, negative 2, negative 1. So from case number 1, we have our solution lying between negative 3. So negative 3 is included. I'm using a dot here up to negative 2. Negative 2 is not a part of the solution, so I'm using a bubble here. And we have from negative 1 to positive infinity. And the other solution is from negative 5 to negative 3. So that means we'll start from x equals to negative 5, which is not a part of the solution, and go all the way up to negative 3, which is not a part of the solution. So that means our solution will be from negative 5. So here, in case number 1, negative 3 is a part of the solution, and in case number 2, negative 3 is not a part of the solution, but that's not an issue here. We only need from one case, so that means negative 3 is included, when we can say that from negative 5 to negative 3 will be one solution, or from negative 1 to infinity. So that means our final solution will be x belongs to negative 5 to negative 2 union negative 1 to positive infinity. So this is a solution to the given linear inequality.